Yeah, with that, I would now like to move on to the other aspect that I had in mind, the broad aspect of unmanned aerial vehicles and their the future, the road ahead. So I would like to maybe start with Professor Ghosh about how he sees the UAV development roadmap, maybe for next 10 years, maybe specific to India, also because of his interaction uh, with private entities and startups. So, Professor Ghosh. Yeah.
Thank you, Ashwini. Am I audible? Yeah. So, when it comes to autonomy of aircraft systems, I mean, it's not like autonomy of a railroad or a autonomy of a car or anything like that. A little louder, okay. Is this better now? Okay. So, autonomy of an aircraft is different from autonomy of ground-based systems. So, about few years ago, the US Department of Defense brought out a vision document. So in the vision document, they actually talked about autonomy and where they see the future is. But remember, that vision document came out before AI and ML became so popular. According to that document, the full autonomy of an aircraft would be something that may happen by 2050, because it required a lot of other things. So with the advent of AI and ML, it could be earlier than that in today's assessment. But then there are two questions: whether we do really want aircraft to be autonomous, or are we, like for example, if I ask you how many of you will take a flight that doesn't have a pilot, I'm sure no one is going to do that. So, but then that is because it's such a new concept. But with advancing years, it may change soon. However, autonomy in aerospace system has a different connotation, in the sense that when you look at this autonomy of subsystems that aircraft has, that is what Amitav Saraf was also talking about, you know. So aircraft carries many subsystems along with it. Those could be autonomous. The full system um, becoming autonomous is perhaps far into the future, but individual cases can be autonomous. In fact, many things that the pilots use are autonomous. Landing gear, you just press a button and the landing gear works. If you want to change the angle of attack, you just press a button, it will happen that way. When the Wright brothers built their aircraft, it was not like that. It was, you have to hold a stick and pull, and that back reaction actually tells you whether you're making a mistake or not, you're doing too much or not, right? So all that has become electronic fly-by-wire and all that. So as you can see that we are going through several levels of autonomy that we are crossing. Now a new entity has entered warfare, that is drones, right? So these drones can be very damaging. They can do many things. They in themselves cannot have a lot of damage, except in one particular case. I'll talk about that. When they fly, they can actually completely immobilize your air defense system. And for that, it doesn't have to be very sophisticated. You just need about 1,000 drones to fly into your area, and your air defenses will just go for a toss, because they will all be reacting to those drones. And if a missile follows after that, they won't be able to do anything. However, these drones are something that can be made fully autonomous. If you take them off, if they take off and they go to another point, they can actually avoid threats, they can do many things, and you can actually program them. Many people who are working on this kind of thing are already working on such problems. So it is possible. The other thing that I want to tell you is that drones are very dangerous things if it falls into the hands of unscrupulous people. For example, imagine a chemical warfare or a biological warfare. If the drones carry such weapons with them, they can lay waste to hundreds of square kilometers in no time at all. So drones are dangerous, and then again, just like you talk about autonomy of bigger aircraft, autonomy of drones is also something that we should think about, that should we have a human intervention there just for the safety of mankind. So I'll stop here and pass on the
Yeah.
baton.
Sure. Other panelists, would you like to add something to this?
So I think I'll pick up on what Amitabh was saying, that we all, like industry, academia, and like national labs, they are all working on algorithms towards autonomy. So DoD community in United States, we are looking around, like, let's say we have making open system architectures. Something like we have iPhone, it has iOS, right? So let's call it DOSA, drone operating open system architecture or something. And then everybody can make apps for DOSA, like PN guidance app or localization app. So they should be compliant to DOSA, right? They have to be, like when my lateral acceleration goes, there should be a standard message.
Yes.
So I think that will help, increase or quickly testing the autonomy stuff, machine learning stuff that we are developing. So I will say open system architecture. There has to be some organization who has to take charge of that. And then when funding agencies give funding, they'll say, oh no, it has to be DOSA compliant, and only we will fund you, or something like that.
Yeah. Yeah, it's interesting that, effective use of autonomous UAVs, you see that interoperability, which is related to compatibility, stands out as a major requirement. Yeah, that's very interesting. So, Professor Rao, I wanted to, if you have any comments in general on UAVs, please go ahead.
I think like autonomy is a very difficult problem to solve, right? I mean,
Yeah.
people have been thinking about this since the 70s, 80s.
Yeah.
How do you solve the closed world problem, open world problem? It's maybe almost bordering like artificial general intelligence. If you can, make an aircraft autonomous and be aware of where it is, I'm sure you can do the same thing to a car or vice versa.
Okay.
I don't see the human element going away anytime soon. However optimistic we may be about AI ML, I am not. That's a different story.
Yeah, that was my next point anyway. So AI and ML is the hot topic. So it appears that there are use cases in perception, right? Because you're entering into new areas, new environments. So a drone can certainly use AI ML tools to identify and plan its trajectory, identify objects, dynamic objects, new objects, take decisions. So what do you think is the sort of the road ahead for drones, for say artificial intelligence to be used?
I think those systems have to be rigorously tested. Just to say I got 97.01% accuracy won't cut it, especially when you're working with hardware.
Yeah.
And given that maybe lives are at stake here.
Right.
Maybe closed problems can still be solved in controlled environments. If you're, we all know about training, testing, sort of diversity you need, and so on.
Yeah.
I don't have an answer to that. We can try maybe something, like I think people have been trying to answer the question of what is round for a long time, right? Maybe now AI ML systems can identify a round thing from a square thing, but still prone to errors. What it is being trained on. So.
Yeah, and specifically to the perception arena where, AI and vision, they go along, right? There's standard test cases there. So for a drone to sort of navigate, do you think that AI can really help it do that faster?
There's just one aspect of the system. The sensors are so crucial. The sort of data that you're getting is so crucial. Like we've been doing some work with satellite images, and then we find that we are not able to pick out many small things, which is large things, sure, you can get it. But if something is very small, depending on the resolution that you have, we tried to use other methods to amplify the resolution. Nothing worked. Yeah. So your algorithm may work, but you also need other systems for the algorithm to be like what he said. You have an abstract level you can work, but you have to implement.
Yeah, safety guarantees and performance guarantees is obviously a question in these. Professor Ghosh, would you like to add on the role of AI ML, if you'd like to touch upon that?
I think we cannot deny that AI ML is here to stay. There are a lot of subsystems, especially those which depend on image processing, right? any kind of image or vision-based systems, I think AI ML has taken over those systems now. No one talks about the old-fashioned image processing algorithms anymore. It's all deep learning. So given that, since the major sensor that we have, major sense that we have, even human beings, is eyes, visual. So AI ML is bound to play a very major role. How would it help in enhancing autonomy? We have to see. If we look at human autonomy, again our vision sense plays a very major role, plus our manipulative abilities. So the vision sense part of it, DL has most probably nailed it. But when it comes to manipulation, I think we are still not there. For example, the recent interview by Hinton actually says that what kind of jobs are still not threatened by AI ML? Plumbers' jobs, right? So they are not, because there's no robot in the world that can get under a wash basin and try to find out where the leak is. But then, let's not laugh it off, because the systems can change. If we have to depend on AI ML, there will not be a case where you need, say, plumber to go in under the wash machine and check something. All you do is you pull it out and put in a new one there, right? So systems will change. So that also we have to keep in mind. So in aircraft also, I think that AI ML will play a very major role. How much we wish to give away our control to this artificial intelligence system is something that we have to decide.
Okay, thanks. So Dr. Raj, I want to move to another aspect. Of course, you are an expert in navigation, and I remember conversations where people would start guidance work with a slide saying that we use perfect information on A, B, C, and D states, and the navigation guys would just look at them. So, I mean, so doing all this, navigation is a challenge, and you talked about it yesterday. So, would you like to say something regarding, say, GPS is a problem as you showed us yesterday? So, any navigational challenges or specific sensors or any of these frameworks which can enable autonomy, a more resilient autonomy with respect to navigation, if you'd like to.
Yeah, absolutely. So, of course, autonomy depends on the localization information, or you need to know. You cannot train machine learning algorithms, or if you don't have knowledge of your states. Of course, you have partially observable or that kind of stuff. But yes, we are looking at alternative PNT solutions, and one of those is magnetic anomaly. So your Earth's core has magnetic signature. So you have buildings and mountains everywhere. So you can make magnetic anomaly maps. And good thing about that is it is unjammable. You have to make a new mountain or a new building next day to change the signature of that. So people are using that a lot now to do navigation. The accuracy is a little bit like you need high-speed vehicles, because what can happen is your magnetic anomaly doesn't change for next 1 kilometer or 2 kilometer, then you are unobservable. Or but if it is a hypersonic vehicle, then it's perfect for hypersonic vehicle, because it will definitely change the anomaly there. Other things are low Earth satellites, or LEOs they call them. They are not meant for navigation, but people have shown, like using Starlink satellites or something, you can use Doppler shift to just one satellite to do positioning there. People are using terrain. So basically it has to be a multi-sensor fusion approach, where if something fails, there is a backup there. Ukraine war, there is no GPS there. It's totally jammed. So when you're flying UAVs, there has to be either vision-based or all the other alternative PNT-based solutions. So yeah, there are solutions there.
Okay, thank you.
Position, navigation, timing.
Yeah, we've been hearing about PN, but PNT, okay.
Timing is important.
Yes. Yeah, I have some more points, and we'll open the floor for questions. But if the panelists feel that there is another point which is important for UAV autonomy, you can please go ahead.
So I can give one example of machine learning AI ML thing. Like for example, FAA, we have ATC, right? Where a lot of folks are already overloaded, and we have seen examples of mishaps happening there. So we have seen work there where, so ATC data is recorded, right? You have historical data from 10 to 20 years or a lot more than that, right? So what people are doing is now, so expert humans, they are recording their commands, what was the aircraft parameters and how they commanded. For just example of runway configuration management. So you have runways where you have to decide whether it will go north to south or south to north. It depends on the wind direction, and the ATC takes that decision based on the data. So based on that, people have trained models now at NASA and FAA, and then they are actually applying that as a just example. They deploy that learned system, and then the FAA operator matches ATC operator. Will I take this decision? The machine learning algorithm. So that way you will develop trust in machine learning algorithms. That okay, I would have taken that decision, or I would have taken that decision. That way, okay, this algorithm is doing what I will do, and then slowly, at some portions, you can. So I think building trust on this AI ML algorithm is an important thing. There.
Okay, thanks.
So in my institute, we have many colleagues who work in the humanities. Now, for them, whenever we talk about the science and technology, I mean, they're STS specialists. So they bring in other dimensions to the use of technology, especially in the way it's programmed or the way it is implemented. There is always some bias in the implementation of any of these systems. I think that's something that we have to be aware of when these are deployed. So there's, if you have ever dealt with a social scientist or somebody in humanities, just ask them for the word actor network theory. Basically, it says that any technology system has human actors, has the technological elements, has a bunch of things. There are always complications, there are always tensions in the way these things are built. And I think as technologists, we have to be aware of them when they're deployed.
Okay, thanks. Yeah, I just wanted to, I mean, many of us work on multi-agent systems and swarms. So just curious to know if operational deployment of UAV swarms, multiple UAVs in an area. So what challenges are there specific to that? There is this thing about centralized control, decentralized control, higher autonomy. If it is decentralized, local decision making and things of that nature. So do you think that the challenges there are more on the algorithm side, or maybe the sensor or the hardware side, or how do you see that area of scaling up, the scalability question? I see now in the autonomous systems discussion, scalability has been added as a formal challenge because swarm robotics is now is an entity there. So I wanted to check.
Yeah, I think it's a very important question here, but because algorithms, I think, are there. I mean, we all develop algorithms, right? But when it comes to implementing those algorithms, then we have a problem because our systems are not as perfect as we assume. Like Ashwini was saying, A, B, C, everything is perfect. That's not the case. They're not perfect. So sensors is a problem. Do they work? How accurate they are? Communication is a problem, especially when you have a large number of UAVs. How do they communicate with each other? If it is autonomy, it has to be with each other and not through a central node, right? So this is a problem. Then the kind of things that we wish our UAVs will do usually never happens. For example, we say that it should follow a Dubin's path, or it should follow a path that will be perfect, like hover and then take a right turn and things. It doesn't happen that way, right? So all these things add to the problem of whether the system will work or not. Scalability becomes very important, because even if you have a system by which you can communicate between 3 drones, how will you do that if there are 30 drones in the area? Your communication system can break down. There could be packet drops. How do the UAV actually work when such things happen? So I think these are the actual implementation challenges. The system level challenges are way more important than the algorithms. The algorithm can do only so much and not much beyond.
Any other comments if the panelists would like?
So recently, I've been like working with a company. I will not name it, but they deliver drones to Ukraine, and they are trying to implement these multi-UAV salvo attacks or things like that. So these are flying munitions or smart munitions, you can call them. Whenever they see target, then because they are small, you have to converge at the same time. So exactly like Dr. Ghosh's point, communication is a problem because there is a bandwidth, right? Once you start adding vehicles, the bandwidth will reduce. One solution will be like frequency hopping or using software-defined radios, where your every vehicle V2V communication can be at a different frequency to increase the number of vehicles that can be operated. And of course, timing, because if you are operating, again, as I said, GPS is main timing source for synchronization, because in simulations we assume the X, Y, X1, X2, X3 that is coming to me is taken at the same time. But once it comes to you, it is not at the same time, or if the clocks are not synchronized. So you have to do a clock synchronization, which is a big research problem. Like, how do I synchronize clocks or time among multiple entities to actually implement this? So timing and frequency hopping. Kind of.
Okay, interesting, very insightful.
If you ask the communications guys, they'll say, look, we've solved all these things. Look at how many 4G users are there.
Right. Okay, I'll now switch to a slightly different kind of point, and I think it would be of interest to our audience because many of us do research in this area. So again, it's a generic point that fundamental or foundational research as against translational research. Of course, these areas have borders or smooth overlapping regions. So any pointers, Professor Ghosh, if you would like to tell the community, a lot of young researchers are here engaging with the outside world, the industry. Most of the people develop algorithms here, and if you have anything to share from your experience.
I have a very personal opinion about this, which may not match with many of you. So when we talk about foundational research, during my time, foundational research meant very theoretical research. When I was a student, people did not talk about translating into industrial applications. In fact, I belong to an age where students were very proud that their work does not have an application. It's completely theoretical. Things change, as they should. So when we talk about foundational research, even translational research has a foundational aspect to it. If you just say that I want to translate my algorithms to a system, that translation requires a lot of fundamental work to be done. Imagine that, so let me give you an anecdote, in the sense a very personal one. I went to Dayton. They have this air museum there. So there are a lot of things there. Something that really struck me is that they have this Wright Brothers aircraft there. And next to the Wright Brothers aircraft, they have a wooden wind tunnel next to it. Turns out that these Wright brothers, we all think of Wright brothers building an aircraft, flying, failing for some time, and then they suddenly flew off. And many of us do not know that they actually carried out wind tunnel tests before they came to a point where this happened. So what I mean to say is that translational research has a lot of foundational aspect to it. Foundational doesn't mean just solving mathematical problems, but there are a lot of other things that has to be done before something can be translated into useful product.
Yeah, thank you. That was very insightful. Dr. Raj, you have had a very interesting trajectory. You worked with multiple organizations and you had a very, very successful phases with universities and organizations. So how do you see the academia industry connect, or in a generic sense its importance, or doing more, sort of engaging more with translational kind of work, or if you'd like to add anything to this discussion, this specific point?
Yeah, absolutely. So one thing, when I was at University of Cincinnati, one thing that we do is instead of 4 year, we have a 5-year program.
Okay.
And the fifth year is like divided as like semester, like 4 semesters of co-op. So in co-op, they have to go and work with the industry. It's a mandatory grade. So the person in charge at the co-op will send the grade. And it's very successful in terms of them getting jobs later on when they graduate, but also bridging that gap that what students are doing at the education, and they are learning while on the work too. So that's what the PID controller stuff, this is what tuning means, or so that's a very good model. And I think internships are a big, even in like my PhD student did 3 internships during her PhD at AFRL. So so it's kind of a good connection, or so they bridge that gap of okay, what the sponsor wants or the lab wants. So that can be cultivated to bridge that gap between industry and academia. And again, a common language.
Yes.
Like iOS thing.
Yeah.
Good thing to have. Like everybody is kind of at the end when their guidance algorithm works, they package it, wrap it around that.
Yeah.
Say, hey, go test it.
Thanks. Dr. Rao, you want to add something?
I think in the academic world, we are in like our own ivory towers, right? Like if you want to really bring something to the market, I think that's a completely different ball game. Like we have an industrial partner. They're right now in the business of electric mobility. But they were electronics guys. They knew how to build power electronics. They knew how to do all these things. So they were trying to build a charger, and they got a very specific material. It was actually not available in India. And then they contacted somebody in the US. The guy asked him, why do you want this specific material? They said, okay, we're building this charger. We need this power electronics element. The guy sent it to him for free. He's sitting in the US, but he sent that very expensive, unique transistor for free. They built it. They got 90% efficiency in the charger, but no buyers. It's like 2x the price or 3x the price. Nobody wants to buy it in India. It's okay. What if it's 40% efficient or 50% efficient? It's only 3,000 rupees. You're asking me 10 grand. Why will I buy it? So you may have the best intentions in the world, but somebody needs to buy it.
Right. Yeah. So we have now about 10 minutes more, and if there is anything specific that the panelists would like to add, please go ahead, or we can take questions from the audience. I think let's do that. So, yeah. Anyone? Any questions, queries in the general theme of the discussion? I do have 1 or 2 more questions, but I'll do that later.
So the main challenge in the computer vision, the weather condition, like when we'll go and implement target detection and that. So the adverse condition like fog and the sun when it will face. So how to tackle that now if at all we'll go for autonomy. So one is this thing, the challenge which we observed, whatever we have developed.
Yeah, that's right. I think many of these things that the traditional image processing fails, so we are hoping that AI/ML can do so. So this hope springs from the fact that even if we see a very hazy image, a human being can actually make sense of it, right? Which an image processing algorithm that depends on finding the contour or edge detection cannot do that. But if we, for example, if you see the silhouette of a person, you know, you will be able to identify that person, right? So AI ML is trying to reach that level where traditional image processing cannot do something, but because human beings are able to do so, can a AI ML system learn that? So that is where the training and thousands of data are required to do this kind of thing. How accurate it is, we do not know, but these things are getting built.
Now, if you are taking the autonomy, like based on the AI and ML, so I'm just telling this is the one of the challenge which
Yeah,
we
I
cannot.
think complete autonomy is still something human beings will not be comfortable with. Whether it is possible is one question. If it is possible, will we be comfortable with it? That I do not.
I can add on this vision thing. So I think today morning somebody talked about digital twins, right? The space robot. I think it was Kaushik and Lee. Okay. So that's one aspect where if your digital twin is so good, then what we have done in some problems is you can introduce these different backgrounds in your synthetic data. So let's say I have two robotic arms, they are trying to do space docking, right? And now we have so many images, or you can now generate images using AI, right? I can say, make stars in the background, make sun in the background, make it more dark. So you use synthetic data to then train, for example, YOLO, you look only once. That's the, I think, most latest computer vision algorithm. So like, I think real data augmented with synthetic data then helps you even recognize these things in foggy conditions. So, and good thing is we can generate these kind of images now, just using simulation and digital twins or.
Hello. Yeah, I have a question. I think maybe Professor Ghosh can start the answer. So he gave a very nice, comprehensive thought about translation and foundational research, right? So when we talk about AI/ML, the difference between like maybe 20 years ago, the research and the translation of that research into industry, the pace at which it used to happen has changed. You can see that the algorithms comes out, CVPR you go, and next year you see that either some of this, Google or some Meta, they're already using those features. And they are already in the market, and they are already influencing the lives of millions of people. Like some of the experiments that we are actually, I feel like we are in an experimental phase where we have this new technology, which is AI/ML, which has a very fast pace conversion rate. It goes into technology, start influencing people's life. So my question is that, what message do you have to the researchers? Because as researchers, we see, oh, this is the buzzword. We run behind it. You get some publication. People, give you like, oh, yeah, this is a good work. But what message do you have to the researcher in terms of looking at a broader perspective to the research that people in the AI/ML community is doing? Because some of it is going to affect, lives. So, yeah, do you have any comments on that? I know that you have, but yeah, it would be nice to have it. Yeah. Yes.
Yeah, no, I think the question is such that it can attract a very broad answers, and we don't have time to discuss everything. But I'll answer only a very narrow part of that question. That is AI/ML as a tool for researchers. So it can work as a tool in many ways. For example, even if I'm doing a research in, say, chemical engineering, where I'm looking at the flow of slurries through a tube or something like that, I would still may like to use AI ML if it makes my life easier, in the sense that if it can create a simulation system that can show me this process. So it's a tool that I use there. Now, do I need to develop that tool for this? Maybe not. It's somebody else that develops that tool. So as a tool, AI ML is a very powerful one which has to be used judiciously, such that many people are using AI ML do not have the capability to say whether it is correct or wrong. And that is where there is a very serious danger. And how do you get out of it is something that many people are thinking of. So I'll just borrow from Terence Tao's lectures. He is perhaps the most famous mathematician in the world. So he gave a few lectures in Cambridge just last year. And this is exactly the question that he was asking. And his solution is that you must have a layer which will assess whether what the AI ML tool gives you is correct or wrong. How do you build that layer is something that you have to apply your mind to, and that is what most probably is the most important research that can happen in this domain. That whether you are able to identify the mistake that an AI ML system makes. So beyond that, I mean, we can talk about it. We have a dinner coming up, so it could be a very good conversational piece there, but I'll stop here. Thank you.
Thank you, Professor.
Hello, Professor Ghosh and other panelists. I would like to know your take on the current push for air taxis, and let's say in a city like Bangalore where hundreds or thousands of air taxis are flying across. Is the current autonomy technology ready for that?
So air taxi technology, I think, has taken off in various places in the world. I mean, yes, even in California, I believe there is a company that's trying to do that. Even in Singapore, there are places. Even in Pune, I saw a company which is trying to build a large drone that can carry people. You know. So these are all at very experimental stages. No one is ready to risk their lives with this, although tests have been done. But if they are successful and they have that they can convince people that they are safe, then they can still work. But whether it will happen in the next 1 year or 2 years, I doubt that. But in the next 5 years, yes, it may happen. But it may not actually happen in the way that you see air taxis all over the place. That may not happen. But it could happen between two important points where air taxi that's more like a human controlled unmanned system. Like there's a ground control for it, it can happen. Like people are talking about air ambulances which are automated. And there is enough technological development that has happened where this is possible now.
You mean to say like specific corridors for such vehicles?
Sorry?
You mean to say like specific corridors for such vehicles could happen sooner?
Well, yeah. The corridors will happen only if there are large number of such vehicles. Otherwise, it doesn't make sense to have specific corridors for these. So if there are large number of them, then certainly there would be corridors too.
So, economy also is an important aspect. Like, of course, before people sitting in it, there will be deliveries like cargo but let's say pizza delivery. People were talking about pizza delivery drones, but an undergrad can deliver 3 pizzas in $5, and for a drone, it is much more costly. Like I think it will cost more than $100 or something. So that's why like Amazon Prime Air or something, they didn't catch up because how can I make money out of delivering drones or air taxis? So air taxis, air delivery, unless they are cheap, I think we have to come to a point where technology converges that it is really cheap and so I think that's the answer.
Yeah. I had a quick question, and I of course don't want to take too much time, and we are already out of time. So I was wondering, again, many of us are from the academic community. So do you think that we need some new specialized graduate programs that may be more tuned towards this specific area, or the way we have been dealing with electrical engineering, aerospace engineering, and that framework is fine? Or do you think there is a need of academic programs to be sort of chalked out, particularly looking at unmanned aerial vehicles and autonomous unmanned aerial systems in general? Or these could be certification courses, or just an academic perspective on this would be helpful, a quick one.
So I can start with, like, instead of changing or starting new programs, we can always add things to the curriculum, right? We can add, even in graduate school, we don't see capstone projects or something. Maybe they can be a part of, there is a 1 semester course, even for MS students or PhD students, to do something hands-on, or you know, or work with the industry, industry-sponsored capstones. So have TCS or you know, IBM or GE give you money that, okay, we will sponsor this 5-student team to solve this particular problem. I think that can be a good thing to do.
Any other comments?
I think in India there is already an initiative to start these programs in different colleges and universities, and the government of India is, MeitY, I think, is spearheading that particular program. But I'm not sure if Shashi Ranjan Kumar is here in the audience. He's there. So actually he is heading that thing in IIT Bombay, where courses which are related to unmanned aerial vehicles are being introduced. It's being introduced in many other places also. Yeah, so there is a program like that here.
Yeah, Shashi, would you like to add some comments to that? We have the benefit of you being here, so why not? Your experience of doing that?
No, so I think there are many institutes, there are across 30 institutes across the country who are trying to develop courses related to drone and making people aware of drone related activities, so that we can have more advancement towards this. Yes, so Kanpur has started MTech program also. So MTech program is started in IIT Kanpur, and there are other institutes who are trying to do it, but again, these are subjected to the approval of Senate and all. So it is not that easy that we decide and we started. It has to be approved by the Senate. So that is taking the time, but I think maybe in next few years we might see many such programs. Yes.
So, yeah, I think he cannot respond. So there are boot camps being organized by all these 30 institutions in India. 5 institutions are heading, and all 30 institutions are supposed to conduct something like 8 boot camps every year, something like that. So there is a number, I don't know exact number, but there is a number. So the idea is that with these boot camps, everybody, I mean, people will be getting trained regarding this.
Professor Chandrasekhar Silamantula from E department, he told that the topics and all have already been discussed about this MTech in RAS, not MTech, sorry, GIT exam in RAS. So next year it might be the one of the subject. Not? Okay, that's what he told this year, maybe later, but that discussion is going on. An automation system.
So NIT Calicut has started a minor on unmanned aerial systems, but it started, so only 2 courses have happened like this. This will be the first batch who graduates from that. So yeah, it's ongoing.
We have a master's program in robotics and automation, and also like a minor program in robotics and automation. And regarding that METE program, I think in our campus also many training programs. It's not like a long duration program. It's like 5 days program headed by like NIT was organizing one such event at our institute. It is like that. Yeah, yeah. We have a guidance and navigational control. Only one in India, I think.